Ladies and gentlemen, please welcome to the stage Senior Vice President of Amazon Web Services, Andy Jassy.
Thank you for being here, and it is my privilege to welcome you to the second annual AWS reInvent Conference. For those of you who are coming for the first time, welcome. For those of you coming back for the second year in a row, welcome back. reInvent is a different type of technology conference. It's not a sales and marketing conference. It's a learning conference. And what we're hoping for is that you learn more about AWS, you learn more about the cloud, you learn about what a lot of your peers are doing in the cloud, and then you take that information back to your own companies and use it and make action out of it to improve your own businesses. We have 9,000 people here in the next few days, and about the same amount watching this via streaming from 57 countries. And the type of companies that are represented here is pretty diverse. It's roughly a third startups, a third mid-sized companies, and a third large enterprises. There'll be over 175 sessions that will be taught, many of which will be taught by partners and customers. There'll be 38 different office hour segments taught by hundreds of AWS engineers here. And then there'll be boot camps that many of you signed up for, certification and training, and then of course on Thursday night, the AWS replay party, which should be pretty festive. So we started working on AWS a little over 10 years ago. And we've been in the market now for 7.5 years. And even though if you look at the stage of our platform today and the robustness of what's available, it's night and day from when we started, we still think about ourselves as 7 years young. And that's because we have so much more coming for you guys, our customers, in the next few years. And yet, in the interim, what we've done is we've built a very robust, fully featured technology infrastructure platform that has great breadth of services and depth of features within those services. And so we've got compute services. Most people know Elastic Compute Cloud, or EC2. We have a number of storage services. We have object storage and Amazon S3, or Simple Storage Service. We have a block store and Elastic Block Store. We have a backup and archival storage solution in Amazon Glacier. We have multiple database services. We have a relational database service called Amazon Relational Database Service, or RDS, that comes in MySQL or Oracle or SQL Server flavors. We have a very high throughput, very low latency, non-relational database service in DynamoDB. And then we have a very broad array of app services that range from Amazon Redshift, which is a data warehouse service, to a content distribution network in CloudFront, to a big data analytics service in Elastic MapReduce, to queuing, to notifications, to email, to search, to workflow, to transcoding, to caching, to mobile push, a very broad array of app services, so it's easier for you to get your applications built quickly without having to reinvent the wheel. And then we have a number of deployment options for you. For those that want to use the APIs of the command line, they can. For those that want to do nothing but use a drop-in container where you upload a file, we automatically provision the instances, the load balancing, the auto-scaling, the monitoring. We have that too in the form of Elastic Beanstalk, which comes in a number of programming languages. And then we have a lot of people services that we've added in the last few years as customers have asked us to do so. So we have a premium support capability for those that want one-on-one technical account management. We have a professional services team that goes in and helps you figure out which workloads should move first to the cloud, and then actually will help you implement the first couple. And then we have certification and training. So a very broad, robust technology infrastructure platform that has breadth of services and then a lot of depth within those services. And I think what we would say, outside of the operational performance and the security of the platform the first 7.5 years, the thing that as a team we're collectively most proud of is the pace that we've been able to innovate on behalf of you guys, our customers. And just for perspective, in 2010, we launched what we considered 61 significant services and features. In 2011, that number was 82. In 2012, that number was 159. And this year, just year to date through today, that number is 235, with a lot more coming in the next 6 weeks. So the pace of innovation is accelerating in AWS. We have a broad geographic footprint, and the way to think about geography in AWS is that we have these constructs which are regions. And a region is a physical place in the world where we have multiple data centers or availability zones. And we have 9 regions in AWS today. We have a region on the East Coast of the United States, 2 on the West Coast of the United States. We have regions in Europe, in Singapore, in Tokyo, in Sydney, in Brazil, and then we have a government-only region called GovCloud, which is for ITAR-compliant workloads, natural U.S. citizen requirements. And then we have 25 availability zones across those 9 regions, and then we have 46 edge locations for our content distribution network, CloudFront. So a very broad geographic footprint, and we're not close to being done adding here. We have hundreds of thousands of customers in over 190 countries, and it's a very broad and diverse group. It ranges from some of the most successful startups like Pinterest and Dropbox and Spotify and Instagram and Airbnb to large enterprises like Netflix and Samsung and Nokia and Dow Jones and General Electric and Philips, Pfizer and Bristol Myers Squibb and Intuit and Suncorp, to the public sector, where we have over 600 government agencies worldwide using AWS and over 2,400 academic institutions. It's a very broad and diverse customer base that's growing very quickly every day. And we also have a very vibrant and large ecosystem of partners that are helping customers build on top of AWS. We always believed from the start of AWS that having a vibrant ecosystem was going to be very strategic because it's what customers want. Customers want help figuring out how to move into the cloud, and they want to be able to run the same software they've been running forever, but just on our technology infrastructure platform. So we have thousands of systems integrators that have built practices and are helping companies move to AWS, from very large ones like Capgemini and Cognizant and Accenture and Wipro and Infosys and Booz Allen, to some of the more up-and-coming regional ones that have grown up in the cloud like Second Watch and Dataluz and CloudPack. And we have a very large number, thousands of independent software vendors or ISVs as well, ranging from SAP and Oracle and Adobe and Autodesk and Infor and Sage. These are all designed to allow you to run the software you want to be able to run on top of AWS's platform. And then about a year and a half ago, we launched something called AWS Marketplace. And this allows ISVs to get more visibility across AWS customers, and customers can buy this software, which is already built to work on top of AWS, and they can deploy it in one click and have all the deployment happen behind the scenes, or they can deploy it at their leisure later on. We have over 25 product categories in the marketplace. We have over 1,100 products. This business has grown over 700% just since the beginning of the year. It's one of the fastest growing businesses in AWS. And as such, we have grown our business very dramatically over the last several years, and it continues to grow at a very rapid pace. This is Gartner's latest Infrastructure as a Service Magic Quadrant, which came out about 2 months ago. And you can see that AWS is in that top right corner, and the other 14 providers are kind of clustered in the middle to bottom left. And Gartner's assessment is that AWS has more than 5 times the server capacity deployed than the other 14 providers combined. So we have a pretty significant leadership position that's accelerating. So why are so many companies, big and small, moving to the cloud so fast? I think there are several reasons. The first question that companies will ask us, whatever size they are, is about security. And it should be their first priority. And that's because if you have customer data that matters, your number one priority as a company is making sure it's secure. That's our number one priority too as a platform. And what we tell customers is that we use all the same strategies and tactics that enterprise technology companies have been using in the security space for the last 30 years. We have very strict physical access control to our data centers. We're very careful to make sure that our network is not intruded in any way. We're very disciplined about wiping our hardware clean when customers abdicate resources. We have all kinds of software and systems that give you more control over who can access your resources, and you can specify which users and which functions and which services. But what's also very advantageous in using AWS is that we have such a large number of enterprises and public sector companies who care a lot about security, who are constantly giving us input on how they want to see us continue to evolve the security features on our platform, that everybody else in the platform gets to enjoy those improvements for free. So there's a real nice network effect here where the more customers that end up on the AWS platform, the more input we get on features and security capabilities, and then the better it is for everybody else because they get to enjoy those benefits for free by virtue of being on the same platform as all these others. We also, over the last number of years, have been asked by enterprises and companies of all sizes to get certifications to make it easier for them to feel comfortable deploying all their workloads in the cloud. And so over the last half a dozen years, we've added these certifications that customers have told us mattered. SOC 1 and SOC 2, ISO 27001. We've made our environment PCI compliant. Customers can run HIPAA compliant workloads in AWS. There's a number of federal certifications we've gotten as well, ranging from FISMA to FIPS to ITAR to FedRAMP. Even in the media space, where we had a number of our large media customers who wanted to put their most secure assets in our cloud, and they wanted us to go out and get the Motion Picture Association of America's highest security certification, we went out and got that because our customers told us it was important. So as we hear things that customers say matter to them in this space, we'll continue to go out and get certifications. I'm excited to introduce a new offering now in the security space that's available today. And that offering is called AWS CloudTrail. And what it is it's a service that logs all the API calls that you're making to your AWS resources. So it tells you who's making the API calls, what they're asking to have changed, which resources are being changed, and where those API calls are coming from. And we store all of that data in S3, or you can archive it to Amazon Glacier if you prefer. And it works in conjunction with all the third-party logging tools that people use today, things like Splunk and Sumo Logic and Loggly. And this allows companies not only to run sophisticated security analysis, but also to better work their compliance and governance. So this is an area that we've gotten a lot of feedback from customers over time. We're excited to offer it today. I think you can expect us to add more things to this service and around this area over time. Customers are also moving to the cloud for availability. And this is a study that was just completed a week or two ago from Nucleus Research. And what they did was they asked a bunch of AWS customers what their availability was before they moved to AWS on-premise, and then after they moved to AWS. And what they found was that after they moved to AWS, they had 32% less downtime than when they were running it on-premise. And that resonates with a lot of the feedback we've anecdotally gotten from our customers, where they feel like their availability has improved since they moved to AWS, and we give them the type of architectures and infrastructure where they can build in a fault-tolerant way. So cost is often the conversation starter in people thinking about moving to the cloud. And there's a lot of pieces to cost when you think about what your own infrastructure is, and then you think about AWS. So the first advantage you get in the cloud is that if you don't have to lay out all that capital in advance for servers and data centers before you know what the demand is going to be, that's a big advantage. To turn capital expense into a variable expense is very attractive to most companies. And then that variable expense is lower in AWS than what most companies can do on their own. And that's because AWS is such large scale at this point that we pass on that scale to our customers in the form of lower prices. There are multiple pricing models in AWS, so you can optimize for what your workload's requirements are. The pricing model that most people know about is on demand. And that's when you pay by the hour, you show up, you use it. When you stop using it, you give it back to us and you stop paying for it. But we also have something called reserved instances that customers who have steady state workloads tend to run on. And with reserved instances, for a small upfront fee, you can choose to reserve an instance for a year or for 3 years, and then you pay roughly half the hourly cost of on-demand. And then we have a third construct called spot instances. And what we do is we take all our excess capacity at any one moment, and we make it available in a spot market. And customers can make a maximum bid for those spot instances. And if their bid is higher than the market clearing price at any one time, they get to run on those instances. And if it's not, they don't. And so for customers who have workloads that can afford to be interrupted or take time to complete, it's a really cost-effective way to use AWS. And so what we find most of our big customers do is they take their steady-state workloads, they run those on reserved instances, and then they fill in the rest of their capacity needs with either on-demand or spot, depending on how fast they need to get that work done and how easily that workload is able to be interrupted. And then the more you use AWS, the less your costs are. We have tiered and volume pricing discounts for customers. For those that are doing big data center migrations or in the process of moving everything to AWS, they often will negotiate custom prices with us. So a great opportunity to save cost across the board in the cloud and in AWS. And the reason that we do this is it reflects a pricing philosophy we have. And we have a really interesting dynamic in our business where we have this virtuous cycle or circle where the more customers we have, the more AWS usage it drives. The more AWS usage, the more infrastructure we have to buy. The more infrastructure we have to buy, we get economies of scale from buying so much. With the economies of scale, it lowers our infrastructure costs, which allows us to reduce our prices, which allows us to drive more customers and spin that wheel. And it turns out that you have opportunities to spin that flywheel faster as you have a larger ecosystem that helps customers move into the cloud, as you have a broad global footprint, as you add more services and features so customers can do more, as you invent and innovate in the infrastructure to lower your costs, all those activities spin that wheel faster. And it's one of the reasons why you've seen us lower prices on 38 different occasions in the last few years, largely in the absence of any competitive pressure to do so. And that's because I've worked at Amazon for 16 years in every one of our businesses. I have never come across customers that have said, I wish I could pay more. And if you have a philosophy like Amazon does and like AWS does, that you start with the customer and everything works backwards from there, and you know that customers care about lower costs, then you work hard to take cost out of your own cost structure and then pass that back to customers in the form of lower prices. We're so obsessed with trying to save customers money that we do things like this, which is our Trusted Advisor program. This is part of our premium support capability. And what we do is we have a number of ways that we can look at customers' setup on top of AWS and try to recommend to them when they may be doing something inefficient. And one of the things we do is we look at customers who are running steady state workloads who are using on-demand instead of reserved instances where they could save money, or we look at customers who have a bunch of idle instances where they're just wasting money. And we proactively reach out to customers and say, hey, do you know you can save money? And this year alone, we've sent roughly 1 million of these notifications, 700,000 of which have been opened and acted on, and that saved customers on an annualized basis $140 million. Now, I ask you, how many technology companies proactively call up their customers and say, could you spend less money with them? Not too many. But that's because we have a different philosophy. Again, we start with the customer and we move backwards from there, and we're trying to build a long-term relationship with customers in a business that outlasts all of us. Even though cost is often what starts the conversation in the cloud, what we have seen as the top driver for companies moving to the cloud over time has been the ability to have increased agility. Why does agility matter? Well, in this day and age, you're at a huge competitive disadvantage if you're not able to move fast. You can look at startups that are on this slide as an example that have moved into pretty stable areas and radically disrupted those areas. Look at what Airbnb has done with hotels. Look at what Spotify has done in the music space, Dropbox with storage, and Instagram with photos, Uber in the taxi space. These were relatively stable businesses that have been really significantly disrupted. Enterprises can't afford to be slow anymore. And yet, if you talk to an engineer or an engineering leader in an enterprise, and you ask, how long does it take to get a server to try an experiment or to put something into Integ, we get answers that range from 6 to 25 weeks. And typically, it's between 10 to 18 weeks is the answer we get. Just think about that. It's demoralizing. And as a company, you just stop trying to invent because you say, why bother? It's going to take so long to get a server if I have an idea and I want to try something. And God forbid it actually works. How am I going to get more servers? Anybody that does a lot of invention will tell you that the two most important factors is, number one, being able to try a lot of experiments, and number two, if those experiments fail, and many should fail if you're pushing the envelope, not having to live with the collateral damage of those failed experiments. In the cloud, you can spin up thousands of instances in minutes. And then, if those experiments don't work out, you can either reuse those instances for other experiments, or you can give them back to us and stop paying for them. That's a huge difference, a big difference in the model. And it means that you can do things like what are in the right column there. You can instantly spin up dev environments or production environments or a 2 petabyte data warehouse and then spin it down, or spin up a 5,000 node HPC cluster and spin it down. It just changes what you can do and what you can try. But what it also does is two other things for your organization. First, it gives people in the organization hope that if they come up with a new idea, it might actually get implemented in a reasonable time frame. And then second, it incents everybody across the entire organization, from the senior-most levels to the junior-most levels, to spend some cycles thinking about inventing because they know they have a chance that it could get implemented. We often get asked, as the cloud has become so pervasive, what's going to happen to our IT teams? And IT teams don't go away. They, of course, work on value-added activities on top of the infrastructure instead of the undifferentiated heavy lifting of racking and stacking. But a question I hardly ever get asked, and I think people should ask, is how do I figure out a way to get more of my employees thinking about new ideas and improvements for my customers? People who work at enterprises want to invent every bit as much as people who work at startups, and they want to improve their customers' experience every bit as much as people who work at startups. They've just been blocked by the infrastructure and the constraints that have been placed by them. The cloud changes all of this. The cloud unleashes innovation up and down the organization. It's no longer a tiny group of people at the top who are thinking about the new ideas. You start to get the new ideas from everybody in the organization. And what that does is it allows you to hire better people, because builders want to actually work at a place where they know they have a chance to impact the customer experience. And it's good for your end users, it's good for your company, it's good for business. So the cloud really is a win across the board in that dimension. So now, is it only speed of deployment that gives you agility? There's no doubt that if you're able to deploy ideas quicker, you're going to be much more agile. However, you still have to actually build the application that meets whatever your idea was. And if you have a way to not have to build all those pieces yourself and to get from idea concept to that fast deployment we were just talking about faster, that gives you a lot of agility. And so that's what you see. There's a lot of confusion sometimes about this point in the cloud. There are people who say, oh, the cloud, that's just a data center. I have data centers. I know how to run data centers. I have colos. And even though there's a huge difference in how you run data centers at scale, and if you get a chance in the next couple days, I recommend going and seeing James Hamilton's presentations on how AWS runs its data centers at scale, because it's very different. and I think you'd find it worthwhile. Notwithstanding that, the cloud and AWS are about a lot more than data centers, even though we have a lot of data centers. You get the infrastructure software, the hardware, and the data center services wrapped neatly together in services like compute or storage or database. And what that means is that you don't have to spend the time or money writing or buying infrastructure software. You don't have to negotiate with hardware vendors to buy hardware and wonder if you're getting a good price or if you bought too much. You don't have to set up and manage data centers and worry about power and network and bandwidth and operating these heterogeneous environments. You get those all as part of these compute, storage, and database services. But then it's about a lot more than just having services. So a lot of people know EC2 and they know S3. And they think, well, you know, I can build a cloud. There are lots of clouds. There are people who have compute services and there are people who have object storage. But a complete cloud that really takes a lot of the heavy lifting away from you has a lot more than compute and object storage. It has block storage. It has backup and archival storage. It has multiple flavors of relational database services. It has NoSQL database services. It has big data analytics services. It has data warehouses. It has queuing. It has notifications. It has email. It has workflow. It has monitoring. It has a broad array of services. And that's what you've seen AWS build over the last 7.5 years. But then, once you've built those services, you can build services that have very primitive capabilities. But what customers really want is they want these services to have real deep features and real deep capabilities that allow them to use them for any way that they could imagine. If you look at the pace of innovation in AWS, and you look at those 235 releases year to date I was talking about earlier, that's what we're doing. We're adding all kinds of features and capabilities in all of these services. And Amazon Redshift is a great example of that. So Amazon Redshift is our data warehouse service. We announced it last year at reInvent, and then we opened it up for everybody in February of this year. And in a little less than 9 months, we have launched 26 new features in Redshift alone. And it took us a couple years to build Redshift. And then in the next 9 months, we built 26 features that continue to improve its capabilities, almost exclusively informed by what you guys, our customers, tell us matters. So you get a broad array of services. You get depth of features within those services. But also, it's not enough if you have a global end user group of people that you need to satisfy to be deployed in 1 or 2 regions in one place of the world. If you've got a global business and you're building applications that need to serve a global end user base, you need to be able to deploy them globally. And as AWS has 9 regions with more coming, you can do that very quickly. So when you think about agility, having the ability to implement ideas quickly and to deploy quickly is a game changer, as we talked about earlier. But it's also the ability to have a broad array of services that you can use with lots of features within those services and a global footprint to deploy to all your end users that you need to satisfy. That's what gives you agility. And when you couple it with a technology provider like AWS that already has a much larger amount of functionality than anybody else in this space, but is also iterating faster than anybody else, you have a long-term ability to be more agile than anybody else and than ever before. So I want to give you the privilege to meet our next speaker. He works at an enterprise that really gets agility. They have a culture of innovation unlike most enterprises I've ever seen before. It's very impressive. And I want to introduce the CEO of Business Services at Suncorp, Jeff Smith.
Thank you, Andy. Thanks, Andy, and good day to everybody. First, I'll give you a quick snapshot of Suncorp. We're a diversified financial services company operating in Australia and New Zealand. We're the 5th largest bank. We're the largest general insurer. The other piece is that our primary mission in life and purpose really is to price and manage risk on behalf of our customers. So our frame of reference is that lots of things go wrong. And then when you combine that with our overall business model, it's quite complex. We have multiple brands, we have multiple products, we have lots of systems, different technologies, and when you combine complexity with lots of things that go wrong, it generates an awful lot of noise that makes it difficult to see opportunity. So our question was, how could we sift through this noise and actually see the opportunity and go on to great achievement? And history has lots of great examples that demonstrate how people overcome great big problems. And there's three common characteristics that I've seen in a number of these examples. And the first is there's no substitute for a good congestion of talent. And the second is there typically some technological achievement that's overcome. And third, and maybe most important, is a leadership culture that combines clarity of purpose, where you really understand the problem you're going to solve, along with passionate curiosity, where you look beyond your own frame of reference and you overcome the obstacles and you solve the problems. So it's a great illustration of this, and it deals with the painting of cars. Now, many of you may not know that cars were actually painted by hand up until the 1920s. And it took 37 days to paint a car, multiple coats of paint, dry it, and ready it for delivery. And the CEO of Dayton Engineering Laboratories Company, which became Delco, his name is Charles Kettering. And he had solved many other problems before. He had invented the electric starter for cars, Freon refrigeration systems, and he was aghast at this. And he challenged his engineers and said, we've got to get better at this. And they told him the most we could ever get this down is 30 days. So he looked beyond his own frame of references, went many places, and he happened upon a jewelry store in New York City, and he found lacquered dishes. And he searched out the lacquer producer, was out of New Jersey, and he connected the lacquer producer with DuPont, who was providing the paint, and they invented a paint thin enough that a car could be spray painted a glossy enamel finish and dried in a few hours. So he took that example back to Dayton, to his head of engineer, took his head of engineer out to lunch and said, I want you to tell me again what's the best you can do. And he said, well, it's going to be 30 days. At that same time, he had some people go and steal that engineer's car and spray paint it a lime green. Brought the engineer back and said, there's your car. And the engineer said, well, that's impossible. And he said, that's your problem. Your job is to make the impossible possible. And he wrote a brief in the newspaper, and it said something like that preconception is a trap, that theories are just the summaries of our past experiences and not the limits of possibility. And I have a saying at Suncorp, which is the windscreen's a lot bigger than the rearview mirror. Why should we be making our future judgments based on our past decisions? So the question is, could we use that inspiration and broaden our own windscreen and look and see if we could stretch that limit of possibility and reimagine the IT landscape? So my CIO, Matt Pencino, and his head of infrastructure and cloud services, Terry Powell, they took it upon themselves to say, we're going to go and make a very, very aggressive plan to move to the cloud. And then they very quickly realized, quite astutely, that when you start planning of what to move, you spend an equal amount of time of what can't be done. And when you spend time talking about what can't be done, that's waste. So they made the very bold and brilliant decision to say, we're going to move everything. And we'll back ourselves to have the talent and leadership to figure out how to overcome those obstacles when they do come up. So the one lesson that we learned out of this is they very quickly honed in. As soon as they decided we're going to do everything, we're going to focus on what goes first and then how to accelerate it. And the lesson we learned out of this is that the broader your vision, the clearer your purpose. And so the other thing that we had to do was talk about, well, how do we actually accelerate this? We've got the technology breakthroughs, we've got Amazon, that's a tick. But we have to provide the talent and the leadership to do this and accelerate this. So what we have going for us is we have an absolutely fantastic culture. It's a battle-hardened culture built on the last 6 years of driving agile principles and practices, along with a very extensive graduate and intern intake over the last 6 years. And some of the things that we hold dear to us in terms of our principles are clarity over certainty, course correction over perfection, self-directed teams over command and control, and then our agile practices which are around continuous delivery, DevOps, and distributed agile. In our distributed agile, we have teams around the world that are connected 24/7 by Skype linked TVs, where the work is assigned not on the role or the hierarchy they're in, but on the skills and the gifts that they bring to the party. And we have a thing, Innovation Day, that we use to reset our own aspirations. We call it a FedEx Day. In those days, we copied it from a company called Atlassian. We didn't invent it in Australia. And the concept behind that day is you can work with whoever you want, you can solve any problem you want. There's only 2 constraints. The first, it's got to be done in 24 hours, so bring your sleeping bags and your pillows. The second is that you have to have working software at the end of the day. So we thought, what if we use that day and orient it toward Amazon? And we did. And so using Amazon technology, we had a FedEx Day that we called Awesome API. And we had 450 people from 10 locations in 4 countries, 42 teams that produced some phenomenal solutions in the course of a day. And Matt Wood from Amazon came down, was in the judging panel, and awarded the winners Kindles. And the lesson that we really learned out of this is that we constantly understate what our capabilities are to solve problems. And that the biggest constraint is never the constraint of time or money. It's generally the constraint of thought. And the key thing is, how do we reset our aspirations to get over the constraint of thought? So finally, where are we? Andy challenged us back at the end of July, says, you guys in 3 months, can you set up a virtual private cloud, virtual data center, have production applications in place by November 1st? And we took that challenge. We overcame all the technical hurdles to do it. We overcame the non-technical hurdles like legal and risk and security and procurement. And the net of it is, on October 30th, we went live with revenue-generating online applications, as well as our BI applications and data streaming. And we are now resetting our own aspirations for what's next. And in the course of that, what we were able to do was create a very intimate, emotional bond with Amazon, where the rising tide is lifting both ships, and my belief is both companies are benefiting outside of the commercial arrangement. So my final advice to all of you here is that any problem can be solved. So look through your windscreen, stretch your limit of possibility and opportunity, and aim for success, not perfection. Because if you don't, you'll lose the opportunity to learn new things in life. Thank you very much.
Thanks, Jeff. Super impressed with what Suncorp has done this quickly. It's very impressive entrepreneurial culture for an enterprise. So, just a reminder on what the benefits of the cloud are. You get to trade capital expense for variable expense. You get a lower variable expense than what you can do on your own. You don't have to guess what your capacity needs are. You have true elasticity. You seamlessly scale up or down as needed. You get much better agility, as we were talking about. You get to take that scarce resource, who are your software development engineers, and instead of having them focus on the undifferentiated heavy lifting of infrastructure, which matters, but hardly ever differentiates your business, you get to spend those resources on things that differentiate your mission, and you can deploy globally in minutes. That's a great set of advantages, and it's compelling, and it's why so many people are moving. And when we launched AWS, in the early days, you had a lot of old guard technology companies saying, there's not really anything new here. This is virtualization. This has been done for a while. And of course, it's a lot more than virtualization. And as customers started voting with their workloads, the old guard technology companies said, no, you're right. This is transformational. The cloud is transformational. What you need, though, is you need AWS in your own data center. You need the private cloud. That's what you want. That sounds good in concept, but when you actually dig into the details, the problem with it is that the private cloud has none of the benefits that I just mentioned. You don't get to trade capital expense for variable expense. It's a high fixed cost, so it's not variable costs that are lower than what you can do on your own. You actually don't get elasticity as an enterprise or a company. You don't get the same agility. You have to manage it yourself, and then you can't deploy globally in minutes. You can't deploy globally easily at all. And so There are some companies or organizations that have regulatory reasons or who have legacy workloads that they just can't stomach moving to the cloud, where they're not going to use the public cloud. But I would argue that number of organizations over time is tiny. If you're not using the public cloud or planning on using the public cloud in some significant fashion, you're at a significant competitive disadvantage. And when we talk to enterprises about that, they understand that, and it makes sense to them conceptually. But then they get worried. They say, well, wait a second. Does that mean I have this binary choice where I either have to do everything in AWS or everything in my own private cloud? And no, that's not a binary choice. We understand that enterprises have a number of on-premise data centers that they're not ready to retire yet. And what they really want is they want the ability to use their on-premise data centers easily with AWS. And that's what we've been spending considerable resource over the last couple of years enabling, and we'll continue to spend considerable resource over the next couple of years to make easier and easier. And you've seen that with some of the things we've launched. So we have Identity Federation. We have the ability to integrate with Active Directory and SAML. We have built a number of networking capabilities. So we have a service called Amazon Virtual Private Cloud, or VPC, that allows you to effectively cordon off a part of our network, deploy AWS resources into it, and then only IP addresses that you bring to bear are the way you can access that. You can also set up subnets that let it be addressable via the internet. And then there's a VPN connection between your data center and AWS. So a lot of enterprises have used the VPC as an extension of their data center topology. Or we built something called Direct Connect, which allows you a private connection between your data center and AWS. You see it with encryption as we continue to encrypt all our persistent stores. You see it with things like a storage gateway that we've built, which is a virtual appliance that allows you to store on premise in a cache your hottest objects that are accessed, but asynchronously be loading all your objects to S3, and then store it in a format where if you want to spin up EC2 instances to do processing on them, you can do so. So you see a lot of these capabilities that enable people to more easily run their on-premise data centers with AWS that we've been building. And then we also have been working with a number of third-party partners to provide easier view so you have a single pane of glass and capabilities of that sort to be able to see your deployment in one spot on-prem and in AWS. We've been working with folks like BMC, Eucalyptus, and CA to make that easier, and you should expect us to continue to do so. Now, it's important to note that we have a pretty different view on how hybrid is evolving than a number of the old guard technology companies. I think that the old guard technology companies believe that what enterprises want is they want to run most of their workloads on-premise behind the firewall, and then they just want to have a little bit of an ability to surge to the cloud. We have a very different view of that. We believe in the fullness of time that very few enterprises are going to own their own data centers. And those that do will have much smaller footprints than they have today. And so that informs our approach of what we're building to make it easier to manage this hybrid world. We're going to meet enterprises where they are right now, but we're going to prioritize making it simple to transition those workloads to where their future homes will be, which is in the cloud. Now, I think that a lot of old guard technology companies aren't so thrilled with how fast things are moving to the cloud. And they're also not so thrilled with how fast things are moving to AWS. And some of these old guard technology companies, I think, are getting a little bit panicky. And so here's an example. This is an old guard technology company based in New York that seems to be pretty worked up about AWS these days. And so they're running these buses in Las Vegas as we speak with these advertisements seemingly protesting this conference. And the advertising is, well, it's creative, I'll say that. I don't think anybody that knows anything about cloud computing would argue that this company has a larger cloud computing business than AWS. But what it is it's a way to jump up and down and to hand wave and to try to distract and confuse customers instead of trying to build comparable functionality to what AWS has. And that's one approach you can take to trying to catch up. It's just a really different approach than ours. What we believe is that you guys, our customers, are what matters most. And we believe that customers are smart. And we believe that customers are not going to allow themselves to have the wool pulled over their eyes easily. And we believe that in this day and age of the internet and transparency that that provides, and given how inexpensive it is to try these technology infrastructure platforms, that customers will figure out what's what. And so as a result, what we focus on is what you guys tell us matters. Delivering more services, more features, high operational performance, and making it simpler for you to improve your business. And that's where we'll continue to focus our energy. And it's why I'm also excited to tell you what's next. So, the idea of virtual desktops has been something that people have been thinking about and working on for a long time. And you can understand why. The ability to centrally manage desktops makes it much easier to manage them and better from a security standpoint. But virtual desktops, which have been around for a while, it's never taken off the way people anticipated that it would. And I think the reasons are, first of all, it turns out to be very difficult to set up. They turn out to be difficult to manage. You have to worry about the hardware. You have to worry about the virtualization software. You have to pay for and worry about the infrastructure still. And so, as a result, this business hasn't really taken off. And we looked at this issue, and we were really asked to look at this issue by our customers, who said, if there's one service that we'd love for you to provide a little bit further up the stack in a solution so we don't have to build it ourselves, it would be desktops. When we looked at this problem, we wondered if there was something we could do to make the problem easier. And so we have built a service that I'm excited to introduce to you now and announce called Amazon Workspaces, which is a virtual cloud desktop service. And what it allows you to do is you get to live that dream of centrally managing your desktops, which makes it easier to manage and better from a security standpoint, but no hardware, no software, no infrastructure, no long-term commitments. You get to pay a low monthly per user fee. The operational performance will be consistent, which has been challenging in the old virtual desktop environments. If you have licenses you've bought already, you can bring those to Amazon Workspaces, or if you want to actually consume licenses from us, you can do so. We have different packages that allow you to do each. And then we have easy integration with your corporate Active Directory. You can access your Amazon Workspace from any of your devices, whether it's a desktop or a laptop or any Android device or any iOS device. And you get persistent sessions so that if you were using your laptop, you were using a workspace in your laptop, and you switch to your Android device, the session picks up just where you left it. But what's also nice is that because it's a cloud service, all of the data lives in the cloud. It doesn't live local to those devices, which is, of course, a concern for an IT administrator. And it's half the price of what the typical virtual desktop infrastructure solution is today. No hardware, no software, no infrastructure, no administration. It's a very compelling value proposition for customers. This is what the pricing looks like for Amazon Workspaces. There are two families of packages. There's a standard package and a performance package. The difference is the capability of the hardware in each. With the standard package, you get one virtual CPU and 50 gigs of storage. With the performance package, you get two virtual CPUs and 100 gigs of storage. And then if you're a company that already has licenses for things like Microsoft Office or antivirus software, and you don't need that pre-installed and you want to bring those licenses to Workspaces, then you buy one of these, either the standard or the performance package, depending on what hardware capabilities you want, at $35 per user per month or $60 per user per month. If you don't want to bring your licenses or don't have them, and you want to have a package that has that licensed software pre-installed, then you pay about $15 more for each of those packages. So it's $50 per user per month for Standard Plus with that software pre-installed, and $75 for Performance Plus. So we're announcing this today. You can start signing up for the limited preview right now, and we'll be admitting people into the limited preview in phases over the next several weeks. So how are enterprises using AWS? We get asked this question a lot, and people say, I understand that enterprises have every imaginable workload on top of AWS. But what I'm looking for, and what would be really helpful for me, is if you can tell me some of the macro strategies that and patterns that you see enterprises using to get on the cloud. So I thought I'd share the 6 most pervasive ones we see. The first is whenever there's a large technology shift, like the cloud is probably the biggest technology shift in our lifetimes, dev and test workloads are the first to move. And you see this here in the cloud as well. We have Lionsgate that's running SAP dev and test workloads on its way to production. The Tokyo Stock Exchange is running Oracle Enterprise Manager 11G environments and dev tests on AWS. Galata Chemicals, which is an additives producer in Connecticut, they're running both SharePoint and ERP SAP dev test environments in AWS. But alongside dev test, the other workloads that tend to go first in a shift like this are altogether new workloads. And those are no-brainers as well. There's no legacy that you have to migrate away from. They're cheaper and less expensive in the cloud. They're easier to build. They're faster to deploy. You get the fault-tolerant architectures you get in the cloud. And you see this here as well, where you've got the Washington Post that's built a social application that has more readership than its newspaper, or PBS that runs its video streaming applications on top of AWS, or Qantas Airlines that's built a hotel and accommodation business and website on AWS called Huru, or Outback Steakhouse that runs all their advertising and marketing campaigns on top of AWS. Dev and test and altogether new workloads are really the workloads that you see enterprises moving fastest. Then there's a third strategy and a fourth strategy which go hand in hand that we've started seeing more and more of over the last 12 months. The third strategy is taking applications that are on-premise and then supplementing them with cloud resources. And you see this particularly in the analytics and the data, the batch processing areas. And here are a few examples. So NASDAQ has a number of market operations applications, and they built these well before AWS got rolling, but they want to do a lot of analysis during the day, and they don't want to have to do it on premise. So these applications do a lot of analysis in the AWS cloud. They move that data back to those on-premise applications during the day, and their consumers get to enjoy that analysis in those applications. Or Nokia has a very large mobile business, and they want to do analytics on what their mobile users are doing. And they had a data center on-premise that was hard to manage, and it was fragile, and it was expensive. And so they started using Amazon Redshift, our data warehouse service, and they're running queries now that finish twice as quickly at half the cost. Or SunPower, which is one of the largest solar power providers in the world, they have applications that they've built to be able to fail over in a disaster recovery scenario in less than 2 hours to AWS. So you see a lot of on-premise applications that are being supplemented by what's available in the cloud. You also see in the fourth strategy the reverse of that, which are applications that have been built in the cloud that reach back to on-premise for resources. So Samsung has built its Smart Hub application on top of AWS, but they really want the transaction, the financial transaction, to happen on their on-premise transaction system. So when customers go to buy content, they get moved over seamlessly to the on-premise transaction system, they complete the transaction, and then they move back to the on-AWS version of the application. So you see it going both ways. The fifth strategy is migration. And this is a strategy that requires a little bit more thinking, a little bit more planning But over the last 14 months, we have seen an explosive amount of enterprise migration to the cloud. And so, a couple examples. Unilever has over 1,000 websites running on AWS, 500 of which they've migrated. And so they've built a pattern and a template to migrate websites quickly to the cloud. And with these websites that are now deployed in the cloud, they can deploy now in 2 days instead of 2 weeks. Or Bristol Myers Squibb, they migrated their clinical trial simulations to AWS. And they now have hundreds and thousands of data analysts tuning these algorithms for these simulations. Not only do these simulations now take just 72 minutes to complete when they used to take 60 hours to complete. Think about how much savings you get and how much more you can do when you go from 60 hours to 72 minutes. But because they've been able to regularly tune these algorithms, because it's so easy to do so in the cloud, they require fewer samples, which is a good thing, given that a lot of the human samples are children. And they're doing all this for about 65% less than it used to cost them when they did it on premise. And you're starting to see a large amount as well of entire data center migration. And you'll hear about that in a little bit. And then the sixth strategy is the all-in strategy, where typically a CEO or a CIO or a CTO, top down, drives the organization to move everything to the cloud. And the case we talk a lot about is Netflix. A few years ago, Reed Hastings decided that he didn't want to have to keep being world-class in running the infrastructure. And they were world-class. They were very good at running the infrastructure. But he saw where his business was heading, and he knew that wouldn't differentiate his business. He wanted to be world-class at providing the best viewing experience for original content. And so they embarked on this journey over a couple of years to move all of their workloads to the cloud. And you're seeing more and more companies make this decision. The Kempinski Hotel Group in Germany just made this decision. You're going to start to hear more and more of these in 2014. And the faster you make this decision, the faster you get all the benefits we've been talking about. The faster you get the cost savings and the capital savings, the faster you can deploy, the faster you can allocate your scarce resources to things that really differentiate your business, the faster that you can actually figure out how to operate in this environment, the faster you figure out the security issues that you have and the compliance issues you have to get through, like Jeff was talking about. If you don't fully commit to it, what happens is teams internally find ways to say no. They find ways to make it go slow, and it takes you longer to enjoy the benefits that you deserve today and that you're going to deserve and you're going to use moving forward. So that's why you get the advantage as you start doing this. A few years ago, when Reed Hastings made this decision, it was a pretty bold decision. I would say today, even though it's a more aggressive decision than migrating a workload here or there, it's not really that crazy or that bold anymore. It's where the world is moving. So, to give you a pretty good example of an enterprise that has realized these various strategies and are actually active deploying them, I want to bring up the global CTO of Dow Jones, Stephen Orban.
Good morning, everybody, and thank you, Andy and AWS, for having me this morning. My name is Stephen Orban, and I run the technology department for Dow Jones, which is one of the 7 companies under the News Corp portfolio. With brands like the Wall Street Journal, the Sun, the Times of London, the Australian, Amplify, and others, our world-class journalism reaches several hundred million people each and every day. Now, while News Corp gives all of its companies a great deal of autonomy to run its businesses, we've realized over the course of the past year or so that there has been an organic convergence in the technology strategy across our global businesses. We've realized that while we produce the world's best journalism and content, we don't yet have the world's best digital platform for distributing that content. One of the reasons that that's been difficult for us is the amount of time and effort that we have to spend in managing our infrastructure. We have 40 data centers across 4 continents, all across the world. Now, for an infrastructure services company like Amazon, that may not seem like a big number, that may be modest. However, for a company who's more concerned with getting its journalism out, the time, money, and people that we need to spend operating these facilities takes away and distracts us from our core mission, which is to build great products for our customers. Why do we want to spend time managing our own virtual private cloud when we can use EC2, who can arguably do it better and certainly do it much more cost effectively? Why do I want to buy the next database rack when I could just use RDS and not have to worry about the operations of the machines and the uptime, et cetera, and I can focus solely on the data model and how I'm indexing my content properly? Why do I want to buy more MTAs to be able to deliver outbound mail when I can just use SES? The answer is, frankly, I don't. So our mission now, over the course of the next several years, is to migrate 75% of our infrastructure from our internal facilities to AWS, leaving us with only 6 physical data centers to manage globally. And we're already well on our way. What started off as a conservative experiment in 2011 with News UK in London has seen broad and rapid adoption over the course of the past 12 months as we realized how easy this was. Significant portions of the Wall Street Journal, dozens of mobile applications and tablet apps that we have across our brands worldwide, and many other applications, including in the back office, are now being hosted on AWS. One of the things that's made this possible and made this much easier for us is the fact that everything in the AWS ecosystem is API-based. This allows us to much more effectively integrate with our legacy applications and our legacy technologies without much concern for what it was developed in, what language we're using, what architecture it's on, because we can just call the web services. In addition to that, we're able to complement the AWS console and the multitude of third-party providers who are out there also servicing and building tools with our own tools. These tools allow us to help govern usage and price much more effectively than we would have ever been able to do in our own environments. Just as a simple example, we have scripts that run every hour or so that survey our environment and look for resources that are underutilized and shut them down. Now, while I may have been able to do that on my own data center, I never would have achieved any cost savings as a result of that because I still had to invest the capital to have that capacity there to begin with. Another key feature for us, which has been mentioned several times already today, is the global nature of the AWS services. It goes without saying that as a global company, we want our infrastructure and our compute to be much closer to our end users to reduce latency and provide a much better experience. But beyond that, it also provides a much better way for us to facilitate collaboration across all the different companies. We've developed an entitlement system in London with the News UK, and very recently we've developed a content recommendation algorithm in New York at Dow Jones, which we're able to share with our sister companies in minutes and hours using CloudFormation, Chef recipes, and AMIs, which would have otherwise taken weeks and months of system administration efforts. So we still have a ways to go. Over the course of the next couple of years, we're going to be migrating 3,000 applications to AWS. We'll survey every single application, we'll look at it, we'll decide if it's a lift and shift. Are we going to re-architect pieces of it for the cloud to take advantage of elasticity or other features? Are we going to take advantage of the AWS marketplace and see if there's things that can complement our would-be hardware solutions? And in all likelihood, in some cases, there will be an opportunity to do some combination of all three. And we feel that combined, this will contribute to a global savings of $100 million in our infrastructure costs, which we're very, very excited to be able to reinvest in product innovation for our customers. But to do all this, we're going to need your help. If anybody here finds this transformation initiative interesting, or if there are developers and designers in the crowd who are interested in coming to work for a dynamic, agile, innovative, and fun team, I'd be happy to hear from you. So please see me this week or reach out to me on LinkedIn and tell me how you can help. Thank you very much for your time.
Thanks, Steve. Amazing what these guys are doing. It's hard to get people in this world to agree on something, but I think we can all agree that mobile devices are not only becoming increasingly more pervasive, but that trend is going to continue to happen for a long period of time. And as such, it's not that surprising that we've built services that are attractive to mobile developers, because the smaller the device that end users are using, the more important the cloud is. And that's because devices are smaller, they have less CPU, they have less disk, so it means they need to reach out to the cloud for that incremental resource. And many of the most popular mobile applications have been built on top of AWS's infrastructure technology platform, using services like EC2 and S3 and DynamoDB, which has kind of become the de facto database for a lot of games and mobile apps. But what I think a lot of people don't necessarily realize is that around the Amazon set of businesses, we have steadily over the last year and a half been adding more and more mobile capabilities. Of course, Amazon, in addition to AWS, has a pretty vibrant device business. And one of the things we've learned across all of our businesses in our interactions with mobile developers is that while most developers don't like the undifferentiated heavy lifting of infrastructure, mobile developers hate it the most. They want to be freed up to just focus on what differentiates their app. And the barriers are so low to getting a mobile app in one of these mobile app stores that they want to go from idea to launch as fast as possible. And that's what we've been doing. Apart from the AWS infrastructure building blocks that mobile developers have been using for a long time, we've built capabilities like Game Circle, which allows mobile developers to use our leaderboards and achievements and syncing services so they don't have to build those in their games or apps. We've built a mobile push service. It's only a couple months old. It's sending tens of millions of pushes per day, so that developers don't have to build that capability themselves. We built Login with Amazon so that mobile developers don't need to worry about identity. They can let their end users use their Amazon credentials or Facebook or Google. We've built an A/B testing service that allows mobile developers to split out sessions and test different treatments, see which ones perform better before they roll that out into production. We built an analytics service called Insights. We built a bunch of ways for mobile developers to make money. So either using our ad network to have ads in their apps, or using our Retail Associates program, where you can merchandise Amazon products and earn a commission, or in-app purchasing, which turns out to be the way that most modern apps and games are making their money today, rather than charging for it up front. And then, of course, we have the Amazon App Store to list your app and let people find it. So I think if you look end to end at the technology capabilities that we make available to mobile developers, there's not a platform that has nearly that amount of functionality. And we're going to continue to focus in this area. So what's next for mobile developers? What's happening is that more and more there are these computationally intensive applications that consumers want to consume. It ranges from sporting events and media events to games to 3D apps, engineering apps. And mobile developers who build these types of things are left with this difficult decision, because end users want to be able to consume these computationally intensive applications on whatever device that they have, large or small. And so what happens for mobile developers who build these types of apps is they have to make this choice. They either have to build it the way they've been building it, which is really rich and computationally intensive, and then they can really only sell it to end users who have high-end hardware, which is a very small portion of the market segment. Or if they want to reach the mass end users who have far less capable hardware, they have to water down the experiences. And so that's kind of an unhappy choice that app developers have to make. And so we looked at this and we wondered, is there a way that the cloud can make a difference here? And is there a service that we could provide that would help mobile developers with this quagmire? And that's why we've launched, and I'm announcing now, Amazon AppStream, which is a flexible, interactive application streaming service for any device. And what it allows you to do is it allows you to build whatever the app is that you want to stream. You stream it from the cloud in AppStream to any device, and it appears to the end user like it's streaming right from their local device. The quality is that high. And the way it works is that AppStream uses Amazon EC2's newest instance family, the G2 instance, which are very powerful GPUs, which means that it eliminates the constraint of end users having less capable hardware and machines. And AppStream will look whenever there's a device that wants to connect to a stream, AppStream connects it with a server. It plans for the right capacity that you'll need so it can scale up when there's more demand. And it provides a consistent streaming experience. Now, as part of this effort, the team built a protocol called Amazon STX. And that protocol is optimized for video encoding and consistent video playback. And so part of what's happening is that it's taking user input, either in the form of what users are doing with the app, or detecting what the network capability is of the end user's device. And it's making adjustments in the stream that it's providing. And so what it means is it means that these app developers who have these computationally intensive apps now don't have to only serve groups of people, the small group of people with high-end hardware on the other end. They now can serve a much broader constituency. It enables streaming applications that I think developers didn't believe were possible before. And it even enables hybrid usage, where you're going to see a number of app developers who only use AppStream for a piece of their application, maybe the heavy rendering part. So it really changes the game for app developers. The limited preview opens today. Come to the website and sign up. We're very curious to see what you build with it. The world is a pretty different place today than it was when we launched AWS 7.5 years ago. I remember when we launched AWS, a lot of the pundits said, nobody's going to really use this for anything. These are toys. And then startups started using these services, and people said, well, no one will base their business on these services. And then startups started building their entire businesses from scratch on top of AWS. And people said, well, enterprises will never use this. And then enterprises started using these services, and people said, well, enterprises will never use these services for anything mission critical. And now, as enterprises in the public sector are using AWS for mission critical applications, there is no longer a question about whether people are going to be using the cloud. The only question is, how fast will all of it move, and which ones will move first? And what's pretty amazing when you reflect on it is that now, today, all the biggest events in the world are being run on the cloud in AWS, whether it's streaming the Super Bowl or the Olympic Games, or whether it's the big reality shows like Dancing with the Stars or Fear Factor that do all their user participation and voting on top of AWS. The Mars Curiosity landing that NASA celebrated last August was streamed live on AWS. The Obama campaign, which many of you have heard about, they built their entire technology capability at AWS. They spun up 200 unique applications in an 18-month period. On election day, they had 7,000 concurrent call center users making over 1 million calls per day, leveraging AWS. They had a database that ran 500,000 transactions per second that was enabling people on the street to be able to figure out who to approach and convince them to vote. They did all that in AWS, and then they spun it all down right after the election. And a lot of people credited their technology platform for why that campaign ultimately was successful. You see it, some of those popular games in the world being run completely on AWS. It's pretty amazing what's happening on the cloud today. And so I'm going to bring up two customers now to give you two further pretty amazing examples. The first one is a customer who built an application for the SEC, the Securities and Exchange Commission, that allows them to store all the market data and all the bid data, and it enables an incredible amount of utility from that. The partner who built that for the SEC is TradeWorks, and I'd like to introduce the president of that partner, TradeWorks, Arjay Kamaray.
Thank you, Andy, and the team at Amazon Web Services for having us here today. So I'm here to talk about the collaboration between my company, TradeWorks Securities, the Amazon Web Services product, and the Securities and Exchange Commission, which you might know as the top regulator of the US stock market, or the top cop policing the market. Now, first a bit about what we do. TradeWorks was founded in 1999 as a financial technology company and trading company, and what we do is we build the technology that powers the infrastructure of the stock market ecosystem. Now you can see a high-level diagram of that ecosystem right there, and as you can see, the stock exchanges put out a tremendous amount of data, approximately 2 million messages a second at peak bursts. They get ingested by trading servers that then analyze that data and make rapid decisions about whether they should buy or sell and send orders back to the stock exchanges. Now, we actually build technology for both sides of that ecosystem. So we have one of the world's fastest commercially available trading platforms with a tick-to-trade response time of about 10 microseconds. And we also have some of the fastest exchange trading technology in the world with a latency response time of about 15 microseconds. Now, in considering the importance of speed, it's not just your response time that matters, it's also how efficiently you handle enormous amounts of data. And I want to share a pretty interesting statistic with you. About 5% of the daily volume in US equities goes through our platform every day. 5%. Now, the number of people that it takes to actually support that platform on a daily basis is about 5. I find that mind-boggling. There are over 250,000 people that work in the US stock market, and if our technology or technology like ours was scaled throughout the industry, then only a fraction of those would be needed to support all this infrastructure. And as you can see, for a 50-person firm, we have a pretty impressive roster of partners and clients that have been working with us. Now, back to the story about the SEC. So there was a transformative date in 2010, and that was the flash crash on May 6th that the SEC had to contend with. And what happened here is that the S&P dropped 4.7% in about 3 minutes. Then it spiked 5.4% in the next 3 minutes. Thousands of stocks were affected, billions of data points were created, and the SEC was called in to investigate. They were essentially put in hot pursuit. Now, what stood in their way was a pretty formidable data challenge. Now, you may think that there are only 2 exchanges out there, but in fact, there are over 70 exchanges or dark pools or ATSs where stocks can trade in the US. And together, they put out about 6 billion records per day. Additionally, another complication was many of the commercially available trading platforms at the time were only able to see down to the level of approximately a millisecond in terms of granularity, but events in the market were happening much faster than that in much smaller increments. And so if you'd want to see down to that level of granularity, then you actually had to download even more data, and then you're multiplying the magnitude of your data challenge. So this brings us to the point of how do you police the world's fastest traders? And if you're a fan of action movies, you know that in every action movie there's a mandatory chase scene at the beginning where the good guys or the cops are chasing the bad guys, and the bad guys somehow get away because the good guys aren't fast enough, or their car has some type of technical problem, or they crash or something. And the lesson there is, if you're trying to police anything, your speed and your capabilities matter. Well, we had a good place to start from. And that was TradeWorks was collecting all the data that was coming out of the exchanges for the past 5 or 6 years. But what that was doing was throwing off about 1 terabyte of data, which generated a demand for finding a place that it could be stored and analyzed efficiently. And the solution for us and for the SEC was to put that on AWS. And the advantages were multiple. There's extreme scalability, extraordinarily fast deployment, highly secure solutions, and a low cost. And in fact, we reckon that for approximately 1/10 the cost of what it would take to build this from scratch, we were able to deploy on AWS, and we're able to get the solution implemented in the SEC in approximately 4 months, which is essentially unheard of in our industry. So, what did we end up building in this 3-way collaboration? I think it's pretty amazing. What we did is we virtualized the stock market and all its history and data that we've been collecting for the past few years. And then we lifted that up and put it into the cloud. And then with the implementation of the Midas platform at the SEC, they were able to reconstruct any market event, any day in history, and be able to watch that in real time, sped up, slowed down, played forward, played reverse, you name it, and run analytics that would allow them to see events that were happening down to the microsecond level and down to the level of the individual records. So, what does that mean for the future? Well, I don't think it's much of an exaggeration to say that the SEC is the world's most advanced financial regulator at this point. With the advent of the Midas platform, to quote Greg Berman, this propels the SEC from 0 to 60 in one fell swoop. And the SEC is already sharing this data on their website and making their analyses public where it's affecting the discourse of what should happen in the future of regulation in the markets. So, in the event that we have some other type of challenge like May 6th or an event of equal complexity, with 2 lines of code, the SEC will now be able to analyze every price tick over all the stocks that traded, over billions of data points, and an analysis that might have taken weeks to months before could be done at this point in something like 2.8 seconds. And the winners here aren't just the SEC and AWS and TradeWorks, but really the investing public, because they're getting markets that are better, safer, and better regulated. Thank you.
Thank you, RJ. So that's a pretty amazing example. Let's move all the way from financial services and the SEC and fade to the entertainment industry, where I'm going to bring up somebody that will show another amazing example of what's being done in the cloud and how the cloud is able to help change the motion picture industry. Same infrastructure challenges, same infrastructure capabilities for how you can use the platform, totally different use case. My pleasure to bring up from Atomic Fiction the co-founder, Kevin Bailey.
So Andy invited me up here on stage today to talk about how my company, Atomic Fiction, uses AWS to create pretty cool imagery for some of today's biggest movies. And before I get into that specifically, I wanted to give you a little bit of background about Atomic Fiction and how we came to be. Now, these are our 2 co-founders, these jokers right here. This is my business partner, Ryan, and I, when we were 7 years old growing up in Seattle. And despite the way that the pom-poms make it look, we're actually super, super tech nerds. We love technology, we love gadgets. And we also loved movies. And it wasn't until we were in high school that we kind of started to realize that there was a really big overlap between technology and the movies we loved. If you look at every one of these movies, they all use technology to create imagery that would not be possible otherwise. And so we geeked out on that, and we started learning 3D computer animation in high school. And with the help of a really amazing teacher of ours, we were able to build up enough of a skill where we got a job with Microsoft in high school. And then 2 days after graduating high school, we moved down to California to start working with Lucasfilm on Star Wars Episode 1. Huge opportunity. I mean, we were absolutely blown away. So 15 years later, when the opportunity came up to start our own visual effects company, we jumped on it. We had new ideas of how we wanted to do things differently than they'd been done in the industry before, but leveraging all of the things that we learned along the way. So we created a space that's nice, big, open, great for artistic communication, and we hired a group of the best people we could possibly find. And that was the most important lesson that we learned over the years in the industry, is that these people here are the most important part of the process. Technology and the economics of that technology are just there to serve their creativity. When a director comes to us and says, I want to see something that's never been seen before, these are the ones that conjure that up straight out of their brains, out of their imagination. They're amazing. Over the last 3 years, we've worked on some pretty cool movies. This is just a little bit of a sampling of them. I'll talk about one of them later in the presentation, but right now, I want to give you a look at a little snippet of the work that we've done so you can get some context for what we do. Go ahead and roll the sizzle bit. We have a cool job. It's awesome. So when we were starting Atomic Fiction, there were two sort of things that we knew that we did not want to do. One was we didn't want to build one of these, I mean, they look snazzy, these server rooms with all this big, power-hungry, expensive equipment that it's hard to cool. But we couldn't even afford to do this if we wanted to. We started Atomic Fiction out of our own pockets. We needed to find a better way to do that. We also knew that those artists that were there in that previous slide, not only are they important, they're really expensive. So we wanted to make sure that every bit of resource that we had was going towards these really cool, creative people. So we decided right from the get-go that we were going to use AWS for all of our computing needs, and we have a lot of them. One of our most computationally intensive processes we call rendering. It's basically taking a recipe, these wireframes and textures and virtual lights and cameras, and taking that recipe and baking it down into the really flashy looking final image that you see in a movie. And that can take a long, long time. So using AWS, we create what we call our render farm, our virtual data center, and we can be Pixar-sized in one moment, and then the minute that we don't need that level of infrastructure, we can go right back down to the iMac that's sitting on an artist's desk. It's really remarkable how we can scale using this tool. We only pay for what we use, and the fact that we don't have any physical restraints on our computational ability means that we don't have any physical limits on the creativity that those artists express. Very important for us. Also really important is that we get faster turnaround without having to pay more. So we can have an artist sitting there for 10 hours waiting for their renders to come back when 100 computers are cranking away on it. Or we can put 1,000 computers on that same task and they'll get it back in 1 hour instead of 10. So the ability to get artist feedback much faster while the creative idea and the change they just made is fresh in their brain is so powerful, not just economically, but also from a creative standpoint. The work actually is better as a result. This is a little bit of a diagram, simplified diagram of how we use the cloud, and we work with a great company called Zinc that manages all the stuff that's in white. And our artists, all they worry about the thing that's in blue, what's on the local server. They have a working directory on the local server, they save their stuff there, they say, hey, kick this off to render, and the transfer into the cloud securely, the instance management, the downloads back to the server, all that happens using Zinc behind the scenes. So at the end of the day, for the artist, the workflow isn't actually much different from what it is at a normal company. All of that's extracted from them. All they care about is that they send stuff off to be rendered and they see a result, and it happens faster for them. It's actually pretty remarkable. It actually simplifies things and improves it. So Star Trek Into Darkness was one of the favorite projects that I've worked on using AWS, and our team cranked away on this for about 4 months at the beginning of the year. Now, when J.J. Abrams and his team came to us and said, hey, do you want to work on Star Trek? We were like, yeah, like, of course we want to work on Star Trek. That's awesome. And so we were so excited about taking on as much work as we possibly could on the film. And JJ is a smart guy. He is wicked smart, sharp as a tack, and he knows exactly what he wants, really demanding, which is a lot of fun for us because it holds our feet to the fire. One of the first scenes that we worked on was called Torpedo Trip. They're trying to defuse a torpedo that's on this little alien planetoid. And we had this reference imagery to start from. It's a bunch of pictures from a black sand beach in Iceland. And that is what we had to start from. About 100 foot by 100 foot patch of gravel, and that's it. And we had to create the entire world out of this. And JJ said, yeah, I kind of want it to look like that beach on Iceland, but it needs to look like an alien planet. But it can't look fantasy. It has to look like something that we could have shot for real. Kind of a tough creative challenge. So we set a concept artist loose on it. And a concept artist paints in 2D. You know, they use Photoshop. Did 25 different iterations on this scene. Normally, I would have to, as the responsible company owner and supervisor, I would have to put a limit on them and say, hey, you can't do this or you can't do this, otherwise you're going to blow through the walls of the company with your ideas. Well, we don't have to do that with AWS. So this was the final image, that the final movie file that is going to play here in a second. There we go. So this is the look. There's steam coming out of crevices, the clouds are moving, and there's millions of three-dimensional rocks that are on the ground that are all lit properly. And so we were able to take her ideas and expand them out through this whole scene. The next scene that we got to work with was the engine room, which was really, really fun. There's a scene in the original Star Trek where it takes place in this location, and he actually shot it in a Budweiser factory in Southern California. Well, in this movie, the Enterprise turns on its side, and it's all kinds of mayhem is going on, and JJ wanted it to look more perilous, and he wanted it to be a lot bigger and not look like a Budweiser factory. So these were our reference images, lots of pipes and shiny metal. This is what we had to start with, a lot of work to do to fill it out. And so we did the same process. We let a concept artist loose on it and didn't limit the number of pipes or how big it could be or how much metal, shiny metal they could use. We just let them have at it. And this is what the final result ended up looking like. So sparks, there's steam rising in order to show what direction the gravity is going in, lots of shiny metal. You know, we just went to town and threw the kitchen sink at it. And some of these frames took up to 25 hours each to render. So there's 24 frames in every second of the movie, and we had to iterate on those 10 times each before they were final. So you can imagine how much computing we had to do. This is another scene. We didn't really have any reference to start with on this. We just said, hey, we want to make it look like bombed out London, and this is what the final shot ended up looking like. It's kind of a frozen moment in time where we get to sort of explore this world. So all the floating paper and smoke and ash particles in the air and all that kind of stuff. We have a lot of fun adding these little subtle details that a lot of people don't even notice. So our AWS story on Star Trek was a really, really compelling one. We were able to start from almost nothing. We actually grew 200% month over month, 2 months in a row, in order to hit the creative requirements of the project, which would have been impossible for a company of our size to do any other way. Because we didn't get any ramp-up time for the film, that makes it further impossible. Even if we were able to build out physical infrastructure, we just didn't have the time. And this allowed us to not artificially limit the creativity of J.J. Abrams or our artists. We could expand as fast as we needed to, as much as we needed to, in order to make the creative happen. And when we were done, we were able to scale back down to 0 in 1 week. And that's really important for 2 reasons. One is, that means we're not burdened by supporting this infrastructure between big jobs. And number 2, it means that we don't have to pass the cost of that unused, unspent infrastructure to our next client, the next job that we go on to. And that lets us make the promise to directors that every dollar that they spend with us is going to end up on that movie screen. And we take that promise very seriously, and AWS allows us to come through on that promise in a very honest way. Then we're done, we archive it all to Glacier, and then we're good. So We obviously really enjoy the work that we do. I hope you enjoyed seeing it, and thank you very much for having me up here on stage today. Enjoy the show.
That is awesome. Kevin and the Atomic Fiction guys blow me away every time I talk to them. It's also amazing how much computation you need even for just 5 seconds of film. It's really amazing. So, as I mentioned earlier, the world is a very different place today. It's never been less expensive to build. It's never been faster to build. It's never been easier to invent. And apart from it being a competitive necessity today to actually invent on behalf of your customers, it's also a lot more fun to go to work if you know you can move the needle and improve the experience for your customers. Don't be denied. Go out and make it happen. And know that we're going to be there every step of the way to help however we can. Thank you very much for listening and enjoy the conference.
Ladies and gentlemen, this concludes today's program. Please rejoin us for tomorrow's keynote at 9 a.m.